So we have talked about the limitations of arrays in the sense that you work with a fixed size. And over here we're going to continue talking about vectors. Vectors are a special type of array with its own little library where it functions as an array, but you don't have to worry about the size because it can automatically grow and contract as the data increases or decreases. Now this program may not be a real good example of how a vector really works, but I'm going to show it anyway. Maybe it's a nice transition from arrays to vectors. We see over here that we declare the number of employees, and this is that pay calculation program again. We have a number of hours, and you have the pay rate for the specific employee. We're going to work with these two in parallel, and maybe that's why we have this size over here, although that's really not strictly necessary. We have two for loops. One stores the data in the array for the hours and the array for the pay rate, and the second for loop reads them in parallel using the same index and then calculates the gross pay. Now I've also shown the memory locations for the arrays in the output, and you'll see that the vectors use consecutive locations the same way as we do that for arrays, and that's really because we work with this fixed size again. So in that sense it doesn't really show us too well what vectors are really like. It goes against the real character of the vectors. Okay, so also notice over here that the hours are actually a vector of integers. That's kind of silly. You also want to have partial hours. I'm going to keep it this way because it shows that we can have two parallel arrays where we have one array integers and another array using doubles. But normally you would take a vector of doubles to store the number of hours. Okay, so over here we're going to add the hours and the hourly pay rates. For loop over here, we use the same index to add to the hours vector and the pay rate vector. And then we're just going to show the output announcement to the user. We're going to make sure that we show 2 decimals for all the doubles. And then we're going to run through a loop again. Now I did manipulate it a little bit with column width and used a W just so I would get enough spacing. Probably could have also worked with tabs, but this made it a little bit more flexible and allowed me to get it really clear. So in the loop we're just going to calculate the gross pay, and then we're going to show the employee number, and then we're going to do the memory location for hours, and then the actual hours that we entered, and then the memory location for the pay rate, and then the actual pay rate, and then we'll say pay with the $sign, and then what the actual gross pay is. So you can see that it actually works. Now this is one of those manual entry programs again, so that will take just a moment. I'll just keep it as simple as possible. 2 and 2.2, 3 and 3.3, 4 and 4.4, 5 and 5.5, and 6 and 6.6, just so you can follow it really easily. So this is what we see over here. We have the employee numbers. Notice that we start counting at 1 over here, and that's because we use the index +1 for the employee label. these are the memory locations and these are the contents. So you see that that matches exactly. Now notice that over here we increase by 4 because each integer is 4 bytes. 0 to 4, 8. C is 12 and then plus 4 is 0, carry 1, and your 3 over here goes to a 4. Over here the memory location for the pay rates. Now the pay rate is a double, so that increases by 8 bytes. 0 to 8, 8 to 0, carry 1, so your 0 increases to 1. 0 to 8, 8 to 0, carry 1, so your 1 goes to 2 over here. And here are the pay amounts, and you can easily see 2 times 220 is 440, 3 times 330 is 990, so that works just fine. The way this is set up, it does not really do justice to the nature of vectors, but we'll get to that in consequent programs.